All right, welcome everybody to another episode of Talking Trout. I'm Mike Coor, former state council chair for Wisconsin Trout Unlimited. I currently serve as our advocacy chair. To welcome you again to first Wednesday of the month. So here we are doing our thing. No April Fool's joke this week. We do not actually have Talking Trout. We haven't found any yet. As soon as we do, we'll get them on the episode. I'm sure there's some people that'll be looking for that on YouTube and might be disappointed. But for the rest of you, I know you're going to be pretty excited as well as I am for a guest tonight, Michael Miller. Michael's a noted author and a stream ecologist with the Wisconsin Department of Natural Resources. Literally wrote the book on the field guide to Wisconsin streams. If you haven't checked that out, I would highly encourage you to do so. Invaluable resource, when you're just out there on the stream side and more want to get more interested in what types of, whether it's bugs or plant life or all the ecology that depends on our cold water resources. So with that, Michael's been doing a lot of really interesting research on a topic that I think us as Trout Unlimited is going to try to put a spotlight on over the next year or so and really take a closer look at this. And that's the Neonicotinoid classification of insecticides that's, typically used right now in the agricultural field. And, many of us anecdotally out on the stream have noticed maybe a decline in, say, mayfly hatches or something like that noticeable over the last couple of decades. And it may have some ties to this. So I won't get into any more, spoil anything. So I'm going to turn it over to you, Michael, and let you have at it.
Thanks, Mike. So the usual question, I'm hoping you can see my screen all right?
I can. That looks great.
Okay, very good. Thank you. I appreciate the introduction, Mike. And one, thanks for everyone for attending tonight. I know this is probably not your typical Wisconsin TU trout talk, but again, as cold water advocates, you need to be obviously aware of factors impacting our resources in the state and elsewhere. So I'm really glad you're attending tonight, and hopefully after the end of this presentation, you'll be much more knowledgeable about the issue of neonicotinoids than you were when we first started this evening. So with that, again, thank you for attending, and I'll start my presentation here. So what I want to cover in the next 45 minutes or so is one, I want to talk about the issue of declines in insect populations, and I'll offer some examples of that both from the terrestrial and aquatic world. And then I'll spend the bulk of the presentation talk about these neonicotinoid insecticides, how they're used or why they're used, and the risks they pose to the environment. And I'll use the term neonics just to kind of abbreviate things a little bit. And then lastly, back in 2021 and 2022, I work for the Department of Natural Resources, and we conducted a survey of streams across the state to see what kind of concentrations of neonics we were finding in Wisconsin's rivers and streams. And again, I'll share some of those preliminary findings. So again, I realize most of you attend these presentations primarily to learn more about new angling opportunities and how perhaps you can increase your angling success. So I'm going to take a 3-minute detour here to thank you folks for listening to this talk about insecticides. So what I did here was with the help of Dan Oley, who's a DNR fisheries manager turned data analyst, he helped me download a data set from Wisconsin, the fisheries department or programs stream survey database. And so we took data from well, the time frame was between 2013 and 2023. So again, all the stream surveys and stream and river surveys that DNR had biologists had conducted throughout this time frame. So I took that data set, and then you see here was represented by nearly 12,000 stream surveys, so lots of data. So I took that data and then I sorted it by both brook trout surveys where brook trout were captured and also surveys where brown trout were captured. So what I sorted it by these two different species, and then what I did was then rank the stream surveys by the greatest numbers of either brown trout or brook trout captured during these surveys. So what you're looking at is, again, some of the highest density surveys, or highest densities of trout, whether it's brook trout or brown trout, found in the streams and rivers in Wisconsin. So I'm going to present that by using a word cloud. So you'll see that in a minute. So you'll see the largest font represents those top 50 streams in the state with the highest densities of either brown trout or brook trout. And then, and also I looked at the next 50 through 100 sites. And then lastly, the smallest font you'll see in this presentation represents those streams that were within the top 150, between the top 150 to 100 stream sites, again, for highest densities of trout found in the streams and rivers in the state. And there's some biases in the sampling effort because we normalize it by, we talk about it.
You want this lay down out here or no?
So,
Yeah.
so thanks for muting your mic.
Yes.
I'm sorry. Are you asking my students?
Okay, so got a little cross chatter there. Okay, so
Please feel no shame in letting me know if you need my help using the Google Doc.
So what we're seeing here is, again, those stream sites in the state with the highest numbers of either brook trout or brown trout. Again, the blue color represents brook trout surveys, and the green color represents brown trout surveys. So again, for some of these streams, for example, the Neonicotinoid River, you're seeing that name show up repeatedly. And the reason that is that over the time frame of this 10 years, there's multiple surveys done. So for some of those surveys, they might have been, again, within the top 150 as far as trout densities were concerned, or the top between 50 and 100 river sites, et cetera, et cetera. So the point is, what you're looking at here is some of the best as far as talking about trout densities in Wisconsin streams. So again, this whole idea of kind of expanding your angling opportunities. Again, if some of these streams are not familiar to you, the names of them perhaps are worth fishing this summer, just to explore some new waters, again, with relatively high densities of fish. So the next thing I wanted to show was kind of in the spirit of trying to improve your angling success. Last week I emailed Tom Rosenbauer. I'd call him a pro angler for the Orvis company, and asked Tom if he'd offer me his top 5 tips for anglers to improve their angling success. So he queried some of his buddies at Orvis, and here's what they came up with for some tips for us to think about when we're out trout fishing if we want to increase our success rate. So that's all I have to offer to improve your angling success and opportunities in the state, but it's your little reward for putting up with the rest of the presentation. So on to the topic at hand. So what's the problem here? Well, the problem is we're seeing significant declines in insects, both terrestrial and aquatic. There's been a number of studies relatively recently published that are starting to highlight this issue. And Mike mentioned at the introduction to this presentation that you folks as anglers, you're kind of eyes on the landscape. You spend a lot of time on streams. Of the people that are out recreating, trout anglers, fly fishers in particular, are most focused on what's hatching, when these hatches occur, how robust these hatches are, that sort of thing. So, people have been mentioning for years now that they've been seeing changes in some of the hatches. Perhaps some of the more sensitive caddisflies, mayflies, stoneflies aren't hatching out in as great a numbers, or perhaps not at all in some of these streams that historically had very good hatches. So that's some very strong anecdotal evidence, and there's also some fairly limited number of research studies that are kind of validating what the anglers are seeing. This particular paper from 2017 by Hallman and others, they did a study, and they've been studying areas in Germany for, again, 27 years, as you can read in the title here, where they're seeing significant declines over time. And this is kind of referred to by entomologists and ecologists as the insect apocalypse paper, because it just kind of painted a pretty grim picture as far as what's happening with insect populations in Europe anyway. And just to back that up with two more studies. So again, these trend lines here show from two other different studies. The one in the middle is from that Allman paper I cited in that previous slide. But again, you don't have to necessarily look at the horizontal axes, the time series, or the y-axis, which are the densities of the insects. You can just look at those trend lines and understand that we're seeing these declines in insect populations. To show this in a kind of more graphical way, for over 100 years, entomologists would take bed sheets and they'd hang them up, spin them on a rope, and then have a gas lantern or electric lamps, and they'd light them up at night. And the insects would be drawn to these bed sheets, and the entomologists either pluck off the specimens of interest to their studies, or they'd oftentimes drape the bed sheet into a vat of ethanol. And the insects that are drawn to lights some of them would fall into the ethanol and drown, and then the entomologists come back the next day and sieve out those insects, and it's begin the arduous task of sorting and identifying those insects. So again, this particular study done in Costa Rica, you can see here the picture on the left is from, as you can read, from 2007, and 12 years later, this is what the population was looking like. Again, they matched up the same time of year, the weather conditions as far as humidity and temperature and wind speeds. So I think it was a pretty comparable comparison between years here. And what these authors, they associate this major decline in nocturnal insects in Costa Rica due to climate change. They're seeing a drying of the rainforests and jungles of Central America. So this is not necessarily a pesticide problem, but we are seeing declines of insects for reasons other than insecticides. So back in the bad old day, farmers and truck drivers in particular, they'd take window screening and they'd affix it to the front of their truck radiators or car radiators, whatever, to prevent their radiators from getting plugged with insects. And unfortunately, we don't have that problem anymore. And some people state that, well, it's because our trucks and cars are much more aerodynamic, and there's something to, certainly something to that. But I'd offer, I probably related this story in the past, but I drive a 1990 Volvo 240, and among Volvo 240 enthusiasts, they're affectionately referred to as Swedish bricks. So my Volvo 240 is about as aerodynamic as a chest freezer. So this issue that the reason we're not seeing strikes on our windshields or fronts of our cars or whatever is because the aerodynamics, at least in my experience, doesn't pertain to my vehicle. And I'll offer some more examples in a minute. Another thing, I live in Madison, Wisconsin. Much of my fishing is done in the Driftless area. So I oftentimes stop in Richland Center. A few years back, they built a new Quick Trip, and usually when I'm coming back from fishing, I'll stop there and get something to drink or eat or whatever, get some fuel, that sort of thing. And I always make a point of when I'm fueling my car, looking up at the lights underneath the canopy. And I've been to this station at night in midsummer and not seen, I could count the number of insects flying around the lights on one hand. So I find that very distressing. There's water bodies near this gas station. Again, the lights that are used here, they are LEDs, so they're cooler, but they still are of a wavelength that attract insects. So again, we're seeing these declines. Much of this data is anecdotal, and again, you fly fishers out there, no doubt, have similar observations. So what are the causes or suspected causes of some of these insect declines? And oftentimes some of the usual suspects, and I'm listing through from here. Again, I'll focus on this issue of increased insecticide use, in particular neonicotinoids, but also there's some thought that habitat loss and climate change is also having impacts on our insect populations. So what is the significance of this? Why should we care? Well, oftentimes ecologists or biologists, they often ask the question, what good is some animal? What good is that midge or mosquito or whatever? And I'd offer that, if you remember back to your 7th grade biology class, we were introduced to the concepts of food chains or food webs. And if you think about that, we're taught that green plants were the primary producers on the landscape, and those in turn are fed upon by primary consumers like insects and so on and so forth up the food chain. So this idea that insects are very important in the food web or food chains is certainly fundamentally important, but please recognize there's a number of other factors that or ecological surfaces that these animals provide. So it's not just providing food for trout or bats or whatever, but a number of other things that are fundamentally important to the functioning of our planet. So next thing I want to touch on is just start to focus on this issue of neonicotinoid insecticides. What are they? How are they used? And again, what threats do they pose to our terrestrial and aquatic environments? So as you can read here, neonics are a synthetic version of nicotine produced by various plant species. I've listed some here in the Solanaceae family. Things seemingly disparate as tobacco and tomatoes and potatoes all produce nicotine to ward off insect pests. And the pests we're seeing here are aphids that are feeding on the underside of this plant leaf. So again, as far as the uses of neonics in the United States, Wisconsin, US, and globally, I'll go through some of the primary applications. One being, and by far and away, the major use of neonics is as a seed dressing, again, on crop seeds like primarily grain crops like corn and soybean and wheat and other small grains, rye, et cetera, et cetera. The seeds are coated with neonics prior to planting and other chemicals. So again, by volume or quantity, seed applications of neonics are by far the greatest usage of these chemicals, not only in the Midwest, but likely in the US and globally. But there's other applications as well. Again, when the crop plants start to grow up later in the season, if there's an insect outbreak, they'll oftentimes, egg producers will spray neonics on the crops. There's also granulated applications. You can think of, say, green spaces and ball diamonds in our urban areas as a turf management tool. So again, it's spread fairly widely in our urban areas. So it's not just an agricultural thing. They're used as root trenches, and we're trying to control things like emerald ash borer, cities and villages, and whatever will soak down the root systems of trees that kill off the ash borers and other tree pests. And they're also used as baits, particularly in urban areas for controlling ants and cockroaches, where they'll apply neonics to various sugars and whatever to attract the insects to kill those pest species. And lastly, there's a number of different topical applications, whether it's for livestock or flea collars that we put on our pets. So you can read here, as far as this use of seed dressing or seed coating of neonics, it's nearly impossible to buy corn for planting in the US that is not treated with neonics, and a very high proportion of the soybeans are treated as well. So even if a ag producer does not want to use these chemicals, they're pretty hard pressed to be able to even purchase seed to use that is not treated with these chemicals prior to planting. So the kind of rationale is among ag producers is that if they buy these seeds with the neonics on, that's one less thing they have to worry about versus having to monitor their fields for pests, and also for a number of different, some different things, so like nitrogen or phosphorus. Ag producers will oftentimes apply more than what's deemed necessary by soil nutrient tests or whatever, and they kind of see this as kind of a risk reduction strategy or insurance policy that, maybe if I apply a little bit more of this, I'll get, there's a good chance I might get a better crop yield, that sort of thing. So I think I truly believe we need to get away from this mindset of ag producers applying these chemicals when there's not a demonstrated need. So there's been some interesting studies done at the University of Wisconsin, Madison, and elsewhere, showing just a vast number of different chemicals that are applied to crop seeds, and you can read them here. Things like insecticides like neonics, but also fungicides, nematicides, and plant growth regulators. And there've been a few studies showing that, frankly, ag producers oftentimes don't even know what is on the seeds that they're buying. But again, there's quite a range of different chemicals that are being applied to the seeds, whether they know what they are or not, or whether they, frankly, if the producers need them or not. So we talk about use the term prophylactic. So again, using something that there's no immediate demonstrated need for it. So again, historically, ag producers, farmers would use a management technique called integrated pest management, and some of the tenets of that are as follows: where producers would rotate their crops, so it reduced the likelihood you'd see a buildup of particular pest species in the crop fields when they rotated their crops. Again, you monitor for the pests, and then if there is a pest outbreak, then you treat when necessary, not just apply chemicals with the thought that maybe it might be a problem, but there might not. And this idea of avoiding broad spectrum insecticides. Again, these neonics are extremely effective at killing insects, but it's not just the pest species that they're killing. There's a broad range of different insects, whether they're aquatic or terrestrial, that are killed by the neonics. And lastly, we should, where possible, try to avoid persistent chemicals. And prior to these seed-applied neonics, which first started occurring, I think, in the mid-2000s, prior to the use of these treated seeds, very few of the fields are actually treated in Wisconsin with neonics. So that kind of points out there, frankly, is that not that much of a problem in this state. There might be some isolated issues, but it is not a widespread problem. So again, we're applying these chemicals, at least historically, they were used relatively in small amounts in the state. So I'm going to walk you through a time series of the use of these chemicals in the U.S. I'm just using one example. Imidacloprid is one of kind of the two or three neonics used in the United States for most crops. And again, imidacloprid is applied to soybeans and corn. So again, these neonics first became commercially available roughly at about 1993, I believe. And again, imidacloprid is just one example of, again, some of the primary neonics currently being used. And as you can read here, the darker the coloration on the map is indicative of higher neonic usage in these geographic areas. So we're starting out in 1995, moving on to 2000, on to 2005, moving on to 2010, 2015. I think I'm kind of seeing a pattern here. So since 2015, we don't really track these chemicals anymore. At least, the state of Wisconsin doesn't track them to any great extent. The EPA has some data, but it's not being shared among the states. There might be some states, I think Minnesota does track neonic sales, but that's not the case in this state. What's going on there is, and again, the US EPA is responsible for the management of pesticides in the US, and there's something called a treated article clause. So when chemical manufacturers apply these insecticides and other pesticides to articles, and an example would be the kitchen sink sponge you have in your home. Oftentimes those sponge manufacturers, they'll apply a bactericidal chemical to that sponge, so your sponge doesn't grow a bunch of bacteria because it's wet and has food sources available to it. So again, when these manufacturers of these chemicals, when they apply them to articles, they don't have to track them as closely as if they're using it as a spray. So the chemical manufacturers in the agricultural world have kind of taken advantage of this loophole. So now we have much less understanding of the amount of these chemicals being applied across the U.S. So what are some of the risks of these chemicals? And I'll spend a few minutes talking about this. Again, is there evidence that neonics are harming the environment? This is not a great graphical. I'll apologize for that time series, but again, on the horizontal axis, get this time series from 1995 to 2015. On the vertical axis is showing the number of publications, studies done on neonics. Now, not all these studies that are measured in the hundreds over time are saying that neonics are detrimental. Many of these studies are studies just showing, where it's showing up in the environment, those sorts of things. But rest assured, if any one of you can go online tonight and type in and do a web search and say, what are the impacts of neonics on pollinators, and you'll see dozens of papers show, populate your computer screen. So for studies of pollinators like bees, no doubt there's dozens and dozens, if not hundreds of papers at this point showing the impacts to pollinators, like whether it's honeybees or moths or other winged insects. And there's dozens of studies relating to impacts on aquatic invertebrates, and I'll touch on those in a few minutes. There's been relatively few studies on fish. There's one study done reporting of finding from Japan where they're applying neonics to the rice paddies that drain into a particular lake, and it caused a collapse of the invertebrate assemblage in that lake, and then as a result, the fish assemblage collapsed as well. So it's kind of a very compelling study where they tracked the concentration of neonics in the lake over a long time series, and it tracked very closely with the declines in both the fish food and the fish themselves. There's been some studies in North Dakota, and perhaps South Dakota, showing impacts to deer where they see changes in growth rates, anomalies in the jaw bones of the deer, and some reductions in the growth of the spleen, and I believe the animals themselves. So it's one of the first studies showing there's impacts to mammals. One of the selling points by the chemical manufacturers of neonics, they say that they're safe for vertebrate animals, but there's increasing evidence that's not necessarily true. There's numerous studies on birds showing the impacts of either loss of their food sources, such as insects, or the birds eating insects that are contaminated with neonics, or birds feeding on seed that's on the ground that is coated with neonics. So dozens, if not hundreds of studies at this point showing impacts to birds. And just recently, there's a report released by the U.S. Environmental Protection Agency, where they estimate that upwards of around 200 different endangered species in the U.S. Are impacted by neonics, 200 out of the roughly 1,800 endangered species in the United States. So it's kind of the first time that I know of that the EPA was kind of making public their findings on the impacts of neonics. So, many people have heard this issue of, colony collapse in honeybees, where I suspect much fewer people have ever heard of the term neonics before. But again, it's not just honeybees being impacted by these chemicals, even though honeybees have kind of captured the spotlight, and that's not necessarily a bad thing. But to me, as a scientist, I find it frustrating that honeybees represent just a very small fraction of the overall insect assemblage out there. So it's not just an issue with honeybees. And just a little fact on kind of toxicity of the honeybees. So a lethal dose of neonics to a test population of honeybees is 5 nanograms per individual bee. So 5 nanograms, that is 5 billionths with a B of neonic, is enough to kill at least half of the test specimens in a study. So again, these chemicals are extremely toxic. And to continue with that analogy, so what is the mechanism of this toxicity? Well, they're neurotoxins. They disrupt the neural communication systems in the bodies of animals, not just bees, but fish and frogs, and remains to be seen what impacts there are to humans. But again, it's a disruptor of our neural networks. Some key things to know as it relates to their impacts to the environment. One, these chemicals bind permanently to these neural receptors in the animals. So as an example, among fly fishers, the beaded mayfly, those larvae may live in a stream or river for maybe 4 or 5 months, and you can contrast that with say a Hexagenia mayfly or a dragonfly, an odonate, that may live as a larvae for upwards of 2-3 years in the water column. So depending on the animal type, they get there's quite a bit of variability in their exposure to these chemicals. And again, the longer you're in that environment, there's a higher likelihood that you're going to be impacted by these chemicals. Also, again, in Wisconsin, we use imidacloprid, clothianidin, thiomethoxam, dinotefuran, and I think there's one other neonic. So there's like 5 different compounds that are commonly used in the state. Again, imidacloprid and clothianidin, 2 of them are by far more widely used. But the point is that all these different chemicals have the same physiological impact on animals. So when we look at concentrations of these chemicals in the environment, we need to look at the total concentrations of these chemicals, not just look at each one of these chemicals individually, because again, each one of these has the same mode of action on the animal. So it is an additive effect. And lastly, as mentioned earlier, neonics are advertised as being safe. Again, depends on what you're talking about. Certainly, they're much safer than DDT and other chemicals to birds and humans and other, mammals in general, that sort of thing. But again, neonics are extremely toxic to many invertebrate species, again, both terrestrial and aquatic insects and other invertebrates as well. And as we're finding out, there's other animal types that are being impacted as well. So to kind of continue with this analogy of this toxicity of these chemicals, as you can read here, if you took 1 sugar granules worth of neonic, again, when you open up your packet of sugar and pour that in your coffee or tea or whatever, one of those little sugar granules, that comparable amount of weight of neonics, as you can read here, is enough to kill 125,000 honeybees. So 1 granule, 125,000 honeybees. Again, if you continue with that analogy, you take that sugar packet that you put in your coffee, depending on the packet, might hold 3 or 4 grams of sugar. Again, as you can read here, that's enough to kill 600 million honeybees. 1 little packet of neonic's enough to kill millions of honeybees. And again, the fact that we're not tracking these things, we apply them by the, we applied neonics by the ton in this state. I did some kind of back of the envelope calculations, and I forget what that number is exactly, but again, we're applying a lot of these chemicals across the landscape, and they're extremely toxic. So some key properties of neonics that are important as we try to understand how they affect the environment. 1, they're water soluble. Again, it's offered that the reason we coat the seeds is that when you plant the seeds, the neonics begin to mobilize and they get taken up through the water into the plant, and it gets distributed through the plant's roots and stem and leaves, and so it's advertised as protecting the entire crop plant. But again, since they are water soluble, that also makes them extremely mobile in the environment. So anytime there's a rain event, again, these things can move off the landscape. And they're very long-lived. There's been some studies showing that even if you stop using these chemicals, they're still persistent for many years. So there's a lot of different factors that affect that. In soil, they're much more longer-lived than in the water column, but rest assured, they're relatively long-lived on the environment, and so they can start to build up over time. Again, there's been a few interesting studies that show that upwards, as you can read here, upwards of 90% of these chemicals actually wash off the seeds and are not even taken up by the crop plant. So again, this kind of fallacy that, yeah, you apply it to the seeds and again, the crops are going to benefit. Again, there's not a number, but a handful of studies that show that that's not the case. So this isn't exactly Rachel Carson's Silent Spring, but way back in 1972 in her breakout album, Joni Mitchell wrote in her song Big Yellow Taxi that the farmers should put away the DDT. Well, so that's DDT, and I'd offer that neonics, they're thought to be somewhere between 7 and 10,000 times more toxic than DDT. So again, we have this long legacy of DDT. Now we're moving into the usage of neonics. And she has this refrain that goes throughout this song that, as you can read here, it always seems to go that you don't know what you've got till it's gone. Well, a sad state of affairs is that right now scientists have identified roughly 1.5 million animals on planet Earth. About 1 million of those are insects, but there's likely that we underestimate the total number of animals on planet Earth by maybe a factor of 5 or 6. So the point I want to make here is, frankly, we don't know what we're losing because we don't even know what we have there. So again, it's kind of an unsettling fact. sorry. So if we so we got 1.2 or 1.5 million animals on planet Earth. Roughly about 400,000 of those animals are beetles. So just beetles alone make up nearly a third of the animal species on planet Earth. So a little segue for the angling community. So we got some interesting early spring snowstorms the last day or so. Well, actually, this photograph was taken in June. This is a Hexagenia mayfly hatch on the Mississippi River. So what that looks like more close up. And no doubt a number of you folks have seen these types of video clips before, but for those that have not seen this, again, that kind of squiggly line in the middle of the graphic here is the Mississippi River, so the border between Wisconsin and Minnesota. And what we're seeing is a Hexagenia mayfly emergence on the Mississippi River occurring during this time series from roughly 9 p.m. to 11 p.m. in one evening on the Mississippi River. So they hatch out in such great numbers that they're actually picked up on Doppler weather radar. There's an interesting study done by Stepanian et al. In 2020, where they're actually using a Doppler radar to estimate the populations of Hexagenia mayflies that are hatching out during these individual emergence events. And for those that fly fish and fish for using Hexagenia patterns at night, you know that these hatches occur multiple times through late June into early July. So it's not just a one-night event. So again, they've been tracking these populations via Doppler radar. They estimate that upwards of, as you can read here, upwards of 20 billion with a B mayflies hatch out on one of these single evening emergences. And they estimate that to represent about, as you can see here, upwards of 100 tons of insect biomass per emergence. And again, I'm not sure what the total number of emergences might be in any given year. No doubt, there's probably 5-6 different emergences, and some are more intense than others. But the point is these estimates of billions of mayflies, hundreds of tons, occurs multiple times throughout the summer months. And they equate that to trillions of calories of energy stored up in those insects. And they also go on to write that again, the Hexagenia emergence is extremely important food source for a lot of different animals, not just birds and bats and trout and mice and fish and frogs. The list goes on. But they estimate just the calories being released from the Mississippi River in this roughly 400-mile stretch could feed 25 million nestlings, from hatch to fledge. So again, extremely important food source, and a lot of different animals actually use this as an environmental cue as to when they should be rearing their young, because it represents a very rich food source. And most disturbing finding of their study was that they're seeing this major decline in the Hexagenia over this 7-year time frame. And it's not just happening in the Mississippi River, but again, the Hexagenia, many that fish with them for trout at night know that they tend to occur in soft sediment streams like the McCann or the Mississippi River or the White, whatever, the list goes on. But point is, these Hexagenia also are found in, again, some of the larger river systems, but also in many lakes as well. And we're seeing the same types of declines in the western Lake Erie Great Lakes Basin, again, where these emergencies were quite prolific, and now they're starting to taper off fairly dramatically. So hopefully I'm making a fairly compelling case here that these chemicals are having very profound negative effects on the environment. So that begs the question, okay, why are ag producers using these chemicals? What sort of benefits do they get from the use of these chemicals? So a very interesting study, and it's cited down in the lower left-hand corner of this slide, done by Cornell University by Trout et al. It's just a very impressive compilation of data. It's like a 440-page report that's sitting on my desk right now. Just a massive effort to compile data on the both the impacts and the utility of these chemicals. And what they concluded was, based on hundreds of field trials, where again they matched up, the different researchers matched up fields where they used neonic treated seeds and compared that with a field trial where they did not use these chemically treated seeds. And as you can see here in this pie chart, the vast majority of the field corn trials, and again, it was done in 15 states, 2 Canadian provinces, hundreds of trials that went into this report, show that the vast majority of these field trials showed no increase in crop yields when they used neonic treated seeds, no increase in crop yields when they used neonic treated seeds. And for that small proportion, 13%, where they did see increases in crop yields, about half the time those increased yields were very modest, didn't even offset the cost of the chemicals themselves. And they also report on soybeans, again, hundreds of field trials, multiple states, a few provinces, all summarized in this Trout et al. Report, showing that, again, the ag producers gain very little from using these chemicals. And so that Cornell University study, very impressive. And I got, obviously, Cornell University is definitely a top flight school, so I respect the science they did there. If it makes you feel a little bit better, there's a very useful, rigorous study done by the University of Wisconsin by Mortzinus and others. And it was not only the University of Wisconsin, but they had collaborators from a dozen other top flight schools. So 13 universities went in on this study, and they concluded in essence the same thing, that when farmers use neonic treated soybeans, they're not getting any improvement in crop yield. So again, and I'm citing some of the verbiage from this particular Mortzinus study, so you can read here for yourself what they concluded. Again, they go on further to say that, based on what we're seeing for impacts to the environment, and again, the literature on that is increasing fairly dramatically, we need to rethink this whole idea of applying these chemicals to seeds, thinking that, again, the ag producers are going to benefit, because there's a preponderance of evidence that suggests they do not. And so why might that be? So this, again, a graphic from this Mortzinus paper. If you look at that salmon colored wedge on the left side of this screen, it represents the concentration of neonics both on the seed coating and then over time as that seed sprouts and there's a young seedling, that sort of thing. So the point being, and then off to the right, you see that bell-shaped curve, purple colored bell-shaped curve, that represents the concentration of aphids in soybean fields. So point being, the aphids don't come on until mid to late summer. And by that time, the neonics are washed out of the plants and not effective at killing the aphids. And I talked to a couple of these researchers, and they said, well, again, for those small proportion of studies where there was increases in crop yields, those are primarily from southern states where apparently the aphid populations come on earlier in the cropping season. So there was some benefit in those areas, but it points to the fact that or the evidence that there's very little benefit to people or the producers in the upper Midwest. So those that don't know, actually, ladybird beetles or ladybugs, whatever you want to call them, they're kind of the tigers of the crop fields, and they're very voracious predators, both as larvae and as the adult here feeding on the aphid in this picture. And there's actually been some interesting studies where when producers use neonics, there's actually an increase in insect pest outbreaks in crop fields because they've killed off all the natural predators. So it just kind of a curious situation. Okay, so hopefully you have some confidence now that neonics have severe negative consequences for both our terrestrial and aquatic environments. Again, there's very strong evidence that ag producers are not benefiting from these chemicals. So who is? So just as an example from Wisconsin, depending on the crop and the application rates, it costs somewhere between $3, maybe $10 per acre to apply neonics to the seeds. And In Wisconsin, we produce somewhere about 4 million acres of field corn, another 2 million, 2.1 or 2 million acres of soybeans in the state. So the point is, if the ag producers in the state are spending somewhere between 20 and $60 million on these chemicals, when again, there's I think a preponderance of evidence that suggests that they're reaping no benefit from these chemicals. And again, at least for field corn, they don't have a choice. The chemical manufacturers and the seed companies are working in concert to buy up all the smaller mom and pop seed producers, kind of forcing the ag producers to have to buy their seeds. And so Bayer Crop Science, Bayer is a German company. You can think of Bayer aspirin. They've probably been around for a couple hundred years. Syngenta is a company out of Switzerland that was bought out by this Chinese National Chemical Corporation. So again, to me, it seems like here are the folks that are benefiting from the use of these chemicals. It's kind of curious. In Germany, there's a ban on the use of neonics. So again, the Bayer company, based in Germany, they can't apply their chemicals in Germany, but again, they're applied by the tons in Wisconsin and elsewhere in the U.S. So lastly, I'll spend about 10 minutes just kind of walk through some sampling I've done in the state over the last few years to show what I was seeing where these chemicals are showing up in Wisconsin streams and rivers. So I did this in 2021 and 2022. 2021 was a drought year, so I kind of ignore that data for now and just focus on data collected in 2022. So not to get bogged down in the gory details, I'd like to think it was a fairly rigorous study. Again, there's 42,000 miles of streams in the state. So what we did was took a GIS layer, a map layer of all the roads in the state and the streams, and overlaid those lines of the roads and the streams. And those intersects, i.e. bridges and culverts, was where that was my sample population. And from that sample population of those road stream intersects, we had a computer do a random draw of a sample population from the overall population. And I'll kind of breeze through this, but so looking at this dot map here, Wisconsin, let's start at the bottom of those different land use stratifications. So again, I had the computer identify those watersheds that are dominated by these 4 different land use types. And again, starting off with the urban sites, so I had a pretty small sample size of 11 urban watersheds where again, we sampled the streams in those urban watersheds, primarily in Milwaukee and the Fox Valley, and one spot just west of Madison. But again, the computer randomly selected these sites. And then you can see in orange the vegetable cropping sites. Many of you are well aware that the Central Sands portion of Wisconsin, Portage County, the Stevens Point area, and Wisconsin Rapids, that area, Pulver. Again, there's the Central Sands. It was a historic glacial lake bed, so the area is pool table flat. The soil is very sandy, great place for growing vegetable crops like potatoes and carrots and peas and beans, that sort of thing. And so whether it's because of the higher application rates on vegetable crops or because of the soil types and the shallow water table, or et cetera, anyways, it's a fairly unique environment, and I'll show some data showing that's a pretty hot spot as far as neonics are concerned. And also I had a computer draw a random population of watersheds dominated by corn and soybeans. And then lastly, that green stratification, non-corn, non-veg, non-urban. The reason I did that was, again, identified watersheds that weren't dominated by urban or vegetable or corn cropping and soybean cropping. It allowed me to combine all this data into a statewide random sample. So if you're kind of confused about this non-corn, non-veg thing, that was the rationale behind that. So how did I interpret the data? There's an interesting study done by Morrissey and others in 2025, and what they had done was they took data from 29 different laboratory studies of toxicity of neonics to various aquatic insects. So based on the concentrations of neonics that they found to be toxic to invertebrate life in those 29 different studies, they summed that up and they came to the conclusion that concentrations of neonics between like 35 and 199 parts per trillion is thought to be chronically toxic to aquatic insects, and concentrations above 200 parts per trillion is thought to be acutely toxic. So those are the benchmarks or thresholds I was using to interpret my field stream sampling data. For those not familiar, this is called a box and whisker plot. So on the horizontal axis, again, we got this population of urban streams, the population of vegetable cropping streams, row cropping defined as corn and soybean cropping. And again, these not urban vegetable or row cropping sites. So on the horizontal or the vertical axis is the concentrations of neonics we're finding in the water column of these streams and rivers in these different types of watersheds. So you can see here that in those vegetable cropping areas, again primarily in the central sands, the concentration of neonics are extremely high, somewhere ranging from a low of about 35 parts per trillion upwards to, actually it's off the scale here, that some of the sites had well over 350 parts per trillion. And I think the average here was about 225 parts per trillion. So compared to these other populations of streams, the vegetable cropping areas are extremely hot as far as neonics is concerned, and you can see the comparison to these other types of land uses. I'll kind of elaborate on that in a minute. So and I'm gonna, in a subsequent slides, I can say, well, maybe 7% of the streams in the state were impacted by neonics, or 17% or 12, whatever. And that may not seem like a lot, but if you think about the fact that if you take all the streams in Wisconsin, straighten them out and line them up end to end, you could encompass planet Earth 1.7 times. So again, we've got 42,000 miles of perennial streams. So even a small percentage of that 42,000 miles is kind of a big deal. So the plots here, again, some histograms. What I want you to focus on is, again, we're talking about chronic impacts and acute impacts, again, based on these different populations of streams. So if we look at the statewide estimate, somewhere around maybe 17% of the streams had constant or chronic concentrations of neonics. And if you look at the acute impacts, it's somewhere maybe around 10%. These things here are called error bars. So there's a 5% chance that the true estimate is outside the bars. So the point is, this data is pretty noisy. It's kind of a weak estimate. Again, I use a population of about 125 randomly selected sites to characterize 42,000 miles of stream. So it's not surprising that we don't have necessarily super tight confidence in the estimates at this point, but rest assured, a significant number of streams in the state have either chronic or acute concentrations of neonics. And again, also recognize that there's many fewer streams in these vegetable growing areas than statewide or in the so the point is, you're thinking, oh man, the vegetable cropping areas, they're very hot. That's very true, but again, also they don't necessarily have a vast majority of a large number of streams. So those streams are impacted, but they're fewer in the number than certainly certainly the statewide and some of these other populations. I just, again, take home message from this plot here is that we're seeing significant amount of chronic and acute impacts across the state, but also we need to get better data to tighten up these estimates. A recent study done at UW-La Crosse, and I'll probably mispronounce the researcher's name, but anyways, it was one of the first studies that I know of that they actually showed toxicity to fish. Again, it's always been characterized that these chemicals are very toxic to invertebrates, but not to vertebrates, whereas with their lab study, they provide evidence to the contrary. And so they concluded at 160 parts per trillion, they're starting to see mortality in the larval stages of these fathead minnows, a common test species used in laboratories. So if you use that data, the fish data, and the 160 parts per trillion threshold, you can see here that maybe roughly around 7% of the streams in the state have, again, the concentrations of this neonic clothianid at concentrations high enough to cause fish mortality. So again, not surprising. Well, it is surprising. The vegetable cropping areas, they use less clothianid, so there's less of an impact in those streams. But certainly in our corn and soybean production areas, which is quite, again, 6 million acres across the state of a 50 million acre state. So again, a lot of the land area in this state is planted in corn. So point is there's high probability that we're seeing impacts to fish in many of these different watersheds. So it's kind of reluctant to show this slide, but I glossed over the fact that when I did the study in 2022, I had shipped a bunch of samples to this lab at Wayne State University in Detroit. And they analyzed for 5 different neonic compounds. Only 3 showed up, but I also split those samples and sent the other half to an EPA lab in Athens, Georgia. And here's a list of the compounds that were showing up in these water column samples I had collected from these 25 streams, just a small subset of the data, 25 streams that I collected data, water samples from in July of 2022. I forgot the exact number here, but there's somewhere between 50 and 60 different chemicals were routinely showing up in the water column sample. So certainly neonics are a big problem, but we need to recognize that there's many other chemicals that are showing up in our surface waters. And I also took some data from some researchers that actually work on it for the USGS here in Madison, Wisconsin, and also out of the EPA Duluth Research Lab, again in Duluth, Minnesota. And they did an excellent study back in 2022. They used some pretty rigorous statistical and laboratory techniques to identify what they feel are the most risk-posing chemicals that we're using in agricultural areas. So we kind of cooked down that number of 50 or 60 sites that I showed in that previous slide down to a handful of fungicides and some number of herbicides and a few other insecticides in addition to the neonics. And interesting thing about the fungicides is, again, they apply to the seeds as well, just like the neonics, to reduce fungal growth on the seeds when they're in the ground. But they can also alter the food chains. Again, insect species, aquatic insects, the larval species. My example here is a giant stonefly. Pteronarcidae is the family name, Pteronarcidae. But they're shredders. That's what they do for a living. When leaves and twigs, leaves primarily, fall in the water in the autumn, again, the chemicals that protect those leaves from insects while they're on the shrubs and trees get leached out, and then these leaves get colonized by fungi and bacteria and algae and other things. So, and it becomes a very rich food source for the aquatic invertebrates. It's kind of the analogy is a cracker with peanut butter on it, where the leaf itself is the cracker, and that biofilm that grows on the leaves when they're in the water is the peanut butter. So again, there's been some recent studies showing that these fungicides are impacting this fungal growth in the streams and impacting not only these shredders, these stoneflies, but other animal invertebrates, insects as well. And these shredders are pretty sloppy eaters, so a lot of the material they shred up washes downstream, and there's other insects, caddisflies and mayflies that capitalize on this shredded food source. So we're altering the food chain by using these fungicides as well. So it's not just the issues with toxicity of insecticides, but some of these other chemicals as well. So perhaps a glimmer of hope here. Back in 2023, the state of New York passed legislation to vastly restrict the use of seed-applied neonics in that state. That's the first time that's happened in the U.S. Again, Canada, much of the European Union, other European countries have banned the use of neonics. So I see kind of a crack in the monolith of the agrochemical business here in the United States, where again, this recent legislation in New York, and just recently, as you can see here, March of 2024, in Vermont, their House of Representatives passed a bill with the hopes, of course, that this gets brought in as legislation in their state as well. So again, I think the kind of writings on the wall for, given the sheer number of studies that are being published on the impacts of these chemicals, the fact that there's, in my opinion, very rigorous data showing that ag producers are not benefiting to any great extent from these chemicals. So again, hopefully there'll be intelligent legislation to help kind of reduce the impact of these chemicals. So just a quick review here. Again, neonics, the most widely used insecticide, not only in Wisconsin and the upper Midwest, but globally. Again, they're widely used as, prophylactically applied to the fields, whether there's a insect or a pest outbreak or not. Again, economic benefit to ag producers, that seems to be in question based on some pretty rigorous studies. Again, some of these physical chemical attributes, again, they accumulate in soil, they're long-lived, they mobilize in the water and end up in our aquatic environments. And then, at least based on some of these preliminary survey work done in Wisconsin, we're seeing it showing up in concentrations that are of concern in our streams and rivers. So as anglers and folks that are very interested in streams that offer this quote from E.O. Wilson. E.O. Wilson recently died about 2 or 3 years ago. He was a Harvard ecologist, and as you can read here, we need to recognize the importance of these small animals on the landscape. For the fly fishers in the audience, again, you're all familiar with caddisflies and net spinning caddisflies. So the animal we're seeing here is again a net spinning caddisfly larvae, lives on the stream bed. I'd offer that probably every trout stream in Wisconsin has these net spinning caddisflies. They're drab little fellows, or maybe a ½ inch long, and they got a Latin name that's maybe about 1.5 inches long. So these crummy little caddisflies. Well, who cares about these stupid caddisflies? Well, the point is they make up the base of the food chain. So if we lose these caddisflies, which make up 1/3 of the biomass in our streams, say goodbye to 1/3 of the sculpin biomass, 1/3 of the trout biomass, 1/3 of the kingfisher biomass, 1/3 of the blue heron biomass. So again, if we're concerned about the functioning of our aquatic ecosystems, we need to think about more than just the trout and some of these other larger, more observable animals. But again, these animals that are critically important to the functioning of our streams are these aquatic insects. So that if there's anyone has any questions, I'll try to answer them. And I appreciate your attention.
Well, thanks, Mike. Really appreciate that, and glad you did a thorough dive into all this. Before we get to the questions, I did promise. I think Andy Martin is with us, and I promised Andy that we would give him a minute. I mentioned at the top of the hour that Wisconsin Trout Unlimited is going to try to shine a brighter spotlight on this issue, and I just wanted to give Andy the floor for a minute to talk about some of the initiatives that we're going to undertake this year. So, Andy, if you're on, I'm going to ask you to unmute.
Thanks, Mike. Can you all hear me okay?
Yeah, go ahead.
Well, thank you, Michael Miller, for that excellent presentation. I was able to catch the last half of it. So just a couple of things. One, Trout Unlimited State Council is hosting a workshop at the Lakes and Rivers Convention next week, a week from today. The workshop is full, and we have 40 participants, and we will have Sean Giblin from Wisconsin DNR, who's worked with Mike also on this issue, and Carla Romano with DATCAP, and AJ Jeniga, who was Mike referred to her in that one slide on her work on fathead minnows and neonics. That will be next week. So that it's a workshop, and it is designed to promote awareness, much of what you heard from Mike. The second thing we have going, which is going to be more a technical forum that we're having that Trout Unlimited is sponsoring, along with UW Extension, Clean Wisconsin, River Alliance, of course, Trout Unlimited, and we have John Simonson also helping us, and several other partners. Have I left anyone out, Michael? I know Michael Williamson's on the call also. Anyway, that will be a technical forum this fall, planned for October 30th. It'll probably likely be held at UW-Madison. We're just forming the steering committee for that event, where we will invite researchers in to put together a forum, a technical forum. And I should say that DNR is also represented on that steering committee to put that together.
Great.
So any questions, anything you want to add, Michael, if Michael Williamson is on the call?
No, only thing I would add, Andy, is that if people are interested in attending or learning more about it, they can either email you, or you can email Mike, and Mike will pass it along. We've worked closely with him in the state council. we did get a grant from DNR to put this forum on. We're looking forward to continuing to explore the use of this pesticide and how it's impacting invertebrates that Mike was talking about earlier tonight.
Yeah, thanks, Andy, and thanks, Michael Williamson, for taking the initiative and taking the lead on that. I guess we're at 9 o'clock, but there are some questions, or a little after 9. So if you're all right sticking around a little bit, Mike Miller, can I fire off a few questions for you?
Do.
I'm going to assume you're okay with that.
Sorry. Yes.
Yeah. Well, let's start with Kent Johnson. You obviously mentioned there are some places around the world who've started banning the use of neonics and even started, here in the States. How do we best, as a volunteer organization, and grassroots members here, how do we best advocate to the state and national decision makers about this issue?
I'm sorry. I was reading one of the chats. Can you repeat that? I apologize. Can you?
Yeah,
pose
Kent
a
was
question?
just wondering if you had some advice on how us as like a nonprofit grassroots organization, how we can best go about advocating on this
Sure.
issue at both the state and maybe national level.
Right. I mean, certainly we need to educate ourselves on the specifics here. Some of the, again, particularly the key things about increased understanding of the impacts of these chemicals, and then also on the flip side, again, ag producers, that anytime there's some effort to rein in some of these chemicals, the cry goes out that we're going to impact the economic structure of the ag community, when in fact, frankly, I think there's pretty strong evidence to show that these chemicals are not benefiting the producers economically. So it seems to kind of shoot down that argument pretty quickly. So we need to get that type of information out there. I kind of see this playing out at the kind of state agency level, where it'll take DNR a couple of years to come up with water quality standards, and the legislature will be kind of slow to move on this. And frankly, I would look to see how New York, with their birds and bees legislation, how did they move this forward? I see New York, and this, perhaps if Vermont passes a similar bill, that might be a good template for Wisconsinites to follow, versus what I see would be more of a protracted effort if we kind of go through water quality standards and then slow adoption of those standards, that sort of thing. So that's I'm not well versed in the political world, but I think look to the success of New York and others, and there's no doubt people in that state would I think be very happy to provide their input on how what worked for them. So I think I try to model what they've done.
Yeah, that's good advice. We appreciate that, and we'll certainly be following along closely as that develops. And it's probably a good thing. Well, it's not a good thing, but it's important for us to remember that it's not just us trout anglers in this box who are dealing with this issue. You brought up the issue with the pollinators and how this affects so much more of our ecosystems than just what the trout are eating on our beloved trout streams. So I certainly appreciate that, and we all need to take a bigger world view as we go into tackling this issue for sure. Is there an avenue for you to present like your findings to the state legislature, or would they have to? We would probably have to have our legislators make a request of the department to have you come in and present some information. Is that how that would have to play out?
That's my guess. What I need to do is, one, kind of put together a fact sheet on kind of what I share with you folks tonight to kind of get that more general word out. I need to write the results up in a peer-reviewed journal article, so it has a little more credibility among different circles. I need to, frankly, do a better job of informing DNR administrators. They're get pretty focused on things like PFAS, and frankly, the squeaky wheel seems to dominate a lot of administers time, whether it's wolves or something else. So, frankly, I think, again, as you touched on a minute ago, Mike, that it's not just in this issue with Trout Unlimited, but again, Audubon Society, and frankly, being the base of the food chain, nearly any environmental group should have some concern about this. So again, building a larger groundswell of interested organizations seems like that'd be beneficial versus just I know Andy Moore had mentioned that the folks that are participating in this workshop or whatever, and that's a great starting point. But and again, it's not my world, but I think reaching out to those other entities that have similar concerns about more intelligent environmental management, just to build up the population of people that are concerned, and a louder voice that hopefully get more attention from our legislators.
Yeah, absolutely. Thanks. David had an interesting question. It made me think about, when you talk about they put the stuff on the seeds, and then the agricultural producers go and put the seeds in the ground, and then it rains and the stuff's water soluble, so it soaks into the ground and it gets into the waterways. Is there, you mentioned that like the life cycle of these chemicals is fairly long. Is there anything that like takes the chemicals out of the environment, or like once they're just there?
No,
We're left to deal with it.
Right. No, again, as a non-chemist, non-toxicologist, I can tell you that, there's photodegradation. So when the stuff ends up in the water column, it'll break down faster than it's in the soil. So again, there's, as I dimly understand, there's some physical chemical processes that do break these things down, and things like pH, and I forget whether it's a high or low pH, but certainly photo degradation against sunlight breaks it down. So yeah, these things do break down, but again, the fact that we're finding it in significant concentrations in the water column suggests that, yeah, this stuff might be breaking down, but there's a ready pool of this that continues to kind of maintain these concentrations. So that's the best I can offer, I guess, at this point.
Yeah, until we can get a handle on stopping it at the source. That's probably priority number one.
That's right. If you don't put out in the environment, it won't be out there, I guess. So
right.
Yeah,
John,
Howdy, I got a question and maybe a suggestion. This is John Cooney. I'm actually calling out from California, but Mike and I have known each other since we were kids. But I am wondering, does Trout Unlimited out in Wisconsin, do they have any avenue to do a little outreach to actual agricultural producers? Get an article in the farmers magazines, or talk to some of these larger farm organizations. I can imagine that a lot of farmers do not exactly know, they're not following, environmental stuff. And as soon as you tell them, no, you can't use something, they're going to give you pushback. But if you get some play in with them, if you go like, listen, farmers, your organizations, I'd like to do a little presentation, and, maybe they can from the get-go just start ordering seed and saying like, no, we don't want these neonicotinoids on the seed, just like we're not buying that product. And there's a lot of organic farmers that won't and can't, and found other avenues for seed than these. So I don't know, I'm just curious as like if there wouldn't be a way to get farmers already to to buy in on the whole deal without actually having to go through the incredibly long, tedious process of legislating. And then you'll immediately get somebody going like, oh, here's another group of environmentalists trying to tell us what to do. And, and it's not, it's a benefit for everybody, as Mike has explained. So just curious as like if there's an avenue for that.
Well, thanks for that. Sorry, Mike, for interrupting. Thanks, John. Good to hear from you. Yeah, I mean, you're right. Again, instead of kind of us versus them, we as whether it's DNR or TU and all these other organizations, we need to talk to these different groups, and whether it's crop consultants or the Farm Bureau or whatever. One, get their understanding of, again, if they feel like these chemicals are extremely important to their livelihood, then let's share the scientific results and say, what is your interpretation of this? Again, I think there's some pretty rigorous studies out there. Again, that data generated by the Ag the chemical companies, it's it's rarely published in the scientific literature. It's gray literature, and it's for proprietary information, so they don't share that type of information. So again, I think there's enough evidence out there that but again, I agree with you, John, that instead of saying no, you can't do this, kind of present it in a different way, that okay, here's what we understand about the value of these chemicals. What do you guys know? And have that
Exactly.
conversation. And again, there's entities like in Wisconsin, we've got the University of Wisconsin Extension. They work with ag producers all the time, so it seemed like they would be a key contact. Kind of all these social aspects of this stuff that I have little understanding or appreciation of. Those folks, that's what they do for a living. So obviously tapping into those technical experts those first lines of contact communication with the ag producers seems fundamentally important. So I'm glad you brought that up, John.
Yeah, thanks, John. And I'll just speak on behalf of Wisconsin Trout Unlimited. You make a really good point. And yes, I do think there is a place for us to reach out to the agricultural community. And I also think about some of the partners that we work with on a regular basis. I'm talking like organizations like the River Alliance of Wisconsin, or Wisconsin Land and Water, maybe Clean Wisconsin. There are a number of organizations who are working on the ground already with farmers who want to be proactive on issues like this. And yeah, we should definitely be making an outreach and a pitch to those folks to get the ball rolling on this. So thanks again for tuning in from California, and appreciate that. So I'm going to try to hit a couple more of these real quick as we're getting late. I know somebody mentioned it, the recording. I'll put it up on our YouTube channel. If you just go to YouTube and search for Wisconsin Trout Unlimited, you should find our channel pretty quickly. And then most of the past episodes are on there, so you can watch them whenever you want. Let's see here. Somebody mentioned, I think it was typed up as, what is the EPS latest stance on neonics? I wonder if John meant EPA there in that question. Michael, do you know, does the EPA have a?
Yeah, and frankly, I'm woefully ignorant in that area, but I know they're kind of reviewing these chemicals. There's some talk of they're going to come out with some sort of reevaluation sometime this year. Again, this curiously enough, where the folks in EPA that work with endangered species have actually published, their position on the impacts to endangered species. So it seems like there's some kind of fracturing of the opinions within EPA, which I see as a good thing, because not that I know this for a fact, but I feel like that entity within EPA that deals with pesticides, I think they tend to err on the side of protecting ag producers, and that's my just dim understanding. So point is, they're hearing greater pressure from other states, and the fact that the European Union has banned these chemicals. So I think the pressure is mounting, and so I think they're going to get forced into being a little more thoughtful about how we manage these chemicals in the near future.
Yeah, thanks, Michael. I'll just mention Sarah Strassman, our TU DARE project manager, just dropped a link in the chat box if folks want to follow up on that. She's got the link to the EPA website of their kind of review on neonicotinoid pesticides. So thanks for putting that out there, Sarah. And then I think previously in the chat box, Jason had dropped a link about the mayfly surveys on I think it was I forget which website, I think weather.gov or weather.gov had a website of mayfly tracking. So Jason put that a couple of links there for you to check out. I'm not sure how much more we really want to get into, Mike. It's getting pretty late here. I really appreciate you, coming on and really great informative presentation. Like Andy and Michael Williamson said, this is definitely an issue that, us as Trout Unlimited, we're going to look for ways that we can engage more on this issue as it, as it continues to emerge and evolve, and as the science continues to come out, and whatever we can do to raise awareness, like we're going to try to be on the front lines of that. So Michael Miller, thanks again for spending some time with us. Thank you for being an advocate for our six-legged, friends out there.
That's right.
They certainly need advocates. So thank you again for joining us. So
I appreciate the opportunity. Thank you.
yeah, thanks. And again, everybody, I'll make sure we get this up on our YouTube channel. So anyone wants to go back and even if you just want to go back and pause that screen or at the beginning where Mike showed the names of the brook trout streams and the brown trout streams. And I know I think I'll be hitting the pause button on that one too. That's an interesting graphic and an interesting way to present that data set. So thanks for giving us that, Mike.
Certainly.
All right, everybody, take care. Have a great night, and we'll see you next month. All right, bye now.
Thank you.